So hello everyone, welcome back. We are going to discuss isomerism. Okay, see, isomerism is nothing but having same molecular formula but different in their arrangement. Okay, structural arrangement. Okay, it is called as isomerism. Okay, so usually there are two types of isomerism. One is structural and other is a stereoisomerism. Structural isomerism is nothing but having same molecular formula but different IUPAC name. Okay, and stereoisomerism is nothing but same molecular formula as well as same IUPAC name. Now, the classification under structural isomerism are chain isomerism, ring chain isomerism, position, functional, metamerism and tautomerism. So, the classification under stereoisomerism is conformational and also configurational isomerism. So, in the configurational isomerism, we have optical as well as geometrical isomerism. So, in this particular video, we are going to discuss structural isomerism, ring, position, functional, metamerism and tautomerism. First one is chain. Okay, so compounds having same molecular formula but different in their number of carbons present in the parent chain. So parent chain is nothing but the longest chain which we choose for the naming. Okay, so these compounds like in the chain isomerism, the compounds which are present, they have the same molecular formula and the parent chain, the number of carbons in the parent chain are different. One thing here, when we see about alkane, methane, propane, so these three does not show isomerism. Okay, up to butane, the isomerism starts from butane, methane, ethane, propane, it does not show the isomerism. Remember that. So chain has more priority than the position C. Now, so this is the line structure. Okay, see here we have 4 carbons. Okay, we have 4 carbons in this parent chain. Okay, 4 carbons is nothing but 10 hydrogens. How? See and see. This ending has 3 hydrogens. Okay, carbon has tetravalency, right? Already we have discussed this all things, basic things in the previous video. So you please see this video. Okay, C4H2. We have endings 3 hydrogen, okay, which is CH3 and this and also CH3. In between you have 2 hydrogen, okay, 3, 3, 2, 2. Okay, it's 10 hydrogen, C4H10 in the parent chain. Coming to this, we have C4H10, parent chain consists only 3 carbons, whereas one branch is present, right? So, the parent chain, the number of carbons are different, but molecular formula same, chain is different. It is called as chain isomerism. Okay, now coming to the position isomerism, having the same molecular formula but different in the positions of functional groups or the substituents. What are functional groups? Functional groups like alcohol group, functional group, halogen containing functional group, nitrate functional group, like that. Okay, see, now we have same molecular formula, C3H8O, C3H8O, same molecular formula, but different in the branches, position of the branches. See, here, the alcoholic functional group, it is present in the first carbon, right? Here, if you see, it is present in the second carbon, the alcoholic functional group. So, the position of functional group, it is different, right? This is position isomerism. Okay, remember, chain has more priority than the position. Yes. One way to find the chain or position isomerism, there is a trick, AB trick we say AB trick. See, now, suppose they gave you 2 structures. Okay, and sometimes chain and position isomerism is quite similar, but we can't identify which is which. So I'll say you one trick, okay, which is commonly called as AB trick. Okay, see, similar, so it is position isomerism. If AB value it is different, then it is chain isomerism. Okay, if AB value different, it is chain isomerism. If AB value is same, it is position isomerism. See, what is A, what is B? A is nothing but the number of carbons in the parent chain. So suppose we have a C4H10O. Okay, so in this, number of carbons in the parent chain is 4. So A value is 4 and the B value are branches of carbon. How many branches are present in this C4H10O? Okay, in this 0. 0 branches are present. So how you write A comma B? 4 comma 0, like that. Coming to this structure, in which one branch is there, of course. So 3 carbon, okay, A value is 3 and B value is number of branches, right? It is 1, 3 comma 1. So these both values are different. One is 4 comma 0 and the other one is 3 comma 1. Both are different, right? So it is chain isomerism, like that you should find. Same, we follow position isomerism. Remember, A is nothing but number of carbons in the parent chain and B is nothing but its branches. Done. I hope you have understood. Now let's move to metamerism. So we have discussed chain and position isomerism. Remember, chain has more than position. Okay, we have to give more priority to chain than the position. Now here comes metamerism. So metamerism comes before the chain. That means metamerism is more stable than chain is more stable than position. Metamerism simple, easy. Okay, same molecular formula but different in the atoms or group of either side of the like bridged functional group. What are they? See, it is ether, thioether, ketone, thioketone, SO2, CO2. See, now in between O is present or between S or between NH, anything it can be. The left and right, the bond formation, you can able to see a bond formation, right? The left side and the right side carbon arrangement are different, then they are said to be metamers to each other. Okay, see here, now for example, with a bridged functional group, we have to keep NH. Now left side carbons, 2 number of carbons are present. Okay, right side 2 number of carbons are present. Okay, done. Next, coming to other structure. Okay, left side 3 carbons are present, right side 1 carbon is present. Okay, it has same molecular formula. Remember that. Should have compulsory same molecular formula. Then only it is said to be isomer. Then it has same molecular formula, yes. But in the case of metamerism, both the arrangement of left and right side carbons, if they are different, okay, if they are different to each other, then they are said to be metamers to each other. In this 2 carbon it is present, okay. In this 3 carbons and 1 carbon is present, both are different, right? Okay, so it is both are metamerism. Okay, 3 carbons, 1 carbon, both are different, so it is metamerism. Here you have 3 carbon, 1 carbon, 3 carbon, 1 carbon, both are metamers, because branches we will not take, right, like that. Normally condition, branched condition. Both sides, left and right side, should be different carbon numbers, so it is said to be metamers. But here 3 comma 1, 3 comma 1, it is same, then it is not said to be metamerism, but it is taken as branched, so it can be metamerism. If in our carbons it is present in the branched condition, we are taken it as metamers only. See here, 3 carbon, 1 carbon, 2 carbon, 2 carbon, both are different, so it is metamerism. See, now we have benzene group here, now we have here hexane. Okay, so both arrangements are different. Okay, both left and right positions are changed, so it is said to be metamers. Remember. Okay, remember. Okay, now let's discuss tautomers. Tautomers అంటే ఏం లేదు, intramolecular H plus transfer. Okay, so what is tautomers? Intramolecular H plus transfer. So we have 3 systems in this, 1, 3, 1, 5 and 1, 2. In these 3, any one tautomer system for tautomerism, okay, then it is said to be tautomerism. So first one, the conditions in which tautomer is like this, it should follow sp3 hybridization, and alpha hydrogen should contain at least 1 alpha hydrogen should be present, okay, and carbon should be sp3. So here keto-enol conversion we will discuss according to 1,3 system. So what is 1,3 system? At the first position, at the third position, we will transfer, okay, what hydrogen until the equilibrium condition is maintained. So here we have one structure. So what you do? So in the keto-enol transformation, send this hydrogen near the oxygen, then what happens? Then the double bond near the oxygen, it rotates. So like resonance is happening here, intramolecular H plus transfer. So according to 1,2 system, intramolecular H plus transfer takes place in first position and second position. So same, it should be same in all the tautomeric form. Okay, so according to 1,5 system, so we have your CH3 single bond, CH double bond, CH single bond, C double bond, OH. Okay, so in fifth position we have 5 alpha hydrogens, right? Sorry. In fifth position we have an alpha hydrogen, okay, it is following sp3 hybridization, then it is said to be tautomer according to 1,5 system. So you see in this structure, here we have 4 sigma is nothing but sp3 hybridization, yes, it follows the tautomerism. Here 4 sigma, sp3 hybridization, yes, it follows tautomerism according to 1,3 system, yes, it exhibits tautomerism. According to 1,5 system, see here, by looking at this, here we have 3 sigma bond and it is sp2. Here also we have 3 sigma bond, that is sp2. So according to 1,3 system, it is not possible that we can say it as tautomerism. But according to 1,5 system, you see, first position we have sp3 hybridization, 1 alpha hydrogen is present. At fifth position also it is sp3 hybridization. So it is said to be 1,5 system. According to what? According to the 1,5 system, we say it has tautomerism, but according to 1,3 system, it is not possible. So if at any system, first you should check whether it follow 1,3 system. If not, you see to 1,2 system, or if 1,2 system is also not possible, then check it out for 1,5 system. So if any of these 3 it is not possible, then it is said to be, it is not tautomerism. Okay, then you go for other isomers. If any of this 1,3 or 1,2 or 1,5 follows, then you say it has a tautomerism. So going to ring chain isomerism, which is the last isomerism, easy, simple. Having same molecular formula, and ring and chain should be present. Okay, one ring should be there, one ring structure should be there, and one chain structure should be there. Okay, it should not both ring only, both chain, it should not be like that. Both should be like different. One should be ring and one should be chain, compulsory. Both chains, not possible. Both rings, not possible. One chain, one ring, it is possible. Molecular formula is same, remember, in isomerism. Okay, now this is ring chain isomerism. It is very easy. Now, structural isomerism priority. Okay, first you should give priority to ring chain isomerism only. Then tautomerism, then functional, then metamerism, then chain, and then positional. Okay, RTFMCP, which is increasing order. Okay, next. So this is structural isomerism. Okay, so in Telugu also I'll explain. In Telugu also I'll explain other video. Now after that we will discuss stereoisomers also in the next video. Okay.